All right, you guys, I hope by now you really know that rational functions are just fractions, but there's a polynomial on the numerator and the denominator. Okay? So again, when we talk about adding rational functions, I want to take you back to the basics. What if I wanted to add 3 over 2 plus 7 over 12? When you are adding fractions, you must have a common denominator. It's much more difficult than multiplying fractions together where you can just multiply the numerators and multiply the denominators. We have to create a common denominator. Now, luckily I only have to do this once here because this is 12 and I know that 2 can go into 12. So I can make this denominator 12 by multiplying by 6. Okay? And if you do this to make a new denominator, you have to do the same thing to the numerator so you don't change the value of the fraction, right? So it's the opposite of kind of reducing a fraction is we're making it bigger. Okay, so what does that give us? So instead of 3 over 2, we get 18 over 12, right? So this whole thing is actually 18 over 12. Now that there's a common denominator, I'm going to keep the denominator. And on the numerator, I'm going to have, now I could write it just like this, and actually this is going to make more sense now that we're doing rational functions. 18 plus 7 all over the common denominator, which is 12, but I can simplify the numerator by actually adding those together, and I think it's 25. I did that super quickly in my head, over 12. Okay? And for simplicity's sake, let's just keep it like this. You could turn it into a mixed number, 2 and 1/12, but let's just leave it as 25 over 12. Okay, so now we're going to start getting a little more creative and a little bit harder, and we're going to actually work with those like adding polynomials. Like, what if I had let's just go down a page, you guys. What if I had, instead of numbers, I have 1 over x, okay, plus, let's just leave this one numbers, right, for once, plus 2/3. Okay, and I need a common denominator. Here's what you do. The easiest thing to do are to multiply the denominators times each other, and you get a common denominator, right? So I can multiply this x by 3 and get 3x, and also if I multiply this 3 by x, I get 3x. Okay, so that's a common denominator. When in doubt, you can just multiply them to get that common denominator. If I multiply this 1 over x by 3 on the denominator, I have to do it by 3 on the numerator. Conversely, if I multiply this side by x on the denominator, I have to multiply this side by x on the numerator. My common denominator is now 3x. And my numerator, this one is 1 times 3 is 3, plus 2 times x is 2x. Now, before, we were able to simplify that numerator by adding it together, but in this case, I can't do it. I am going to rewrite it with my 2x's first, though, just because it's the common way to write things with the variable first. So 2x plus 3 all over 3x, and it has to stay that way. My denominator's there. That's my common denominator, but I cannot add 2x and 3 because there's no like terms, right? So I've added it together, and this is now what I have. But let's do a couple more practice problems before you start your own. All right, I grabbed this problem here. We want to, oh, this is a subtraction problem. Oh, good, we can practice distributing our negative. Now, how in the heck are we going to get a common denominator there? You know what, let me clear the screen here. Let's do this over here. How are we going to get a common denominator? Well, here's the thing. The first thing you want to do is factor the denominators to see what we actually have in common, okay? So let's go ahead and do that. This first one, so this is going to be equal to, we leave 6 over And if I factor that, let's see, two numbers that add up to be -3 and multiply together to be -4, that's going to be x minus 4 and x plus 1. Okay, minus 4 over, and hopefully we'll have something in common here. Two numbers that add up to be 1 positive and multiply together to be -20. So that's going to be x plus 5 times x minus 4. Cool, so we're almost there, right? Each one has an x minus 4, but then this one has an x plus 1, and this one has an x plus 5. So if I just, what is each one missing? This first denominator is missing an x plus 5, and the second denominator is missing an x plus 4. So over here, let me just erase something really quick. There we go. Over here, if I multiply this by x plus 5 over x plus 5, okay, it'll get me x minus 4 times x plus 5 times x plus 1. And if on this side I multiply it by x plus 1 over x plus 1, all three terms on the denominator are going to be the same. So that's going to be my new denominator. My new denominator is actually going to be x plus 5 times x minus 4 times x plus 1. Oh, again with these horizontal lines I can't draw. Okay, what's my numerator going to be now? My first one is 6 times x plus 5, right? Minus 4 times x plus 1. Now, let's actually simplify this and see if we can reduce this any more. Okay, let's go ahead and distribute that 6 times x and then 6 plus 5. That gives me 6x plus 30. And then -4 times x and -4 times 1. So we have minus 4x minus 4. Now I have some like terms I can combine. So actually, I'm not going to touch my denominator right now, but I'm going to remember that that's my denominator, okay? But I'm going to keep simplifying over here, just the numerator. So 6x minus 4x, I get 2x. And positive 30 minus 4, I get plus 26. And just for kicks, I'm going to factor out, I see I can factor out a 2 there, and I want to do that just in case there's something I can cancel in the denominator. But no, there's not. So I could leave the numerator either as 2x plus 26 or as 2 times x plus 13. It doesn't matter. It's simplified the same. But I like to have it out like this. So plus 13 all over. Remember, that was just the numerator. My denominator is still x plus 5 times x minus 4 times x plus 1. Okay, so I subtracted those two rational functions, and the answer I got was this whole piece right here. Okay, let's go ahead and do another practice problem. Let's go down a page. All right, you guys, how about this one here? Let's do this one. Okay, so first things first, my first thought is I'm just going to factor out, these both have, this denominator has, let's see, each of those terms on the denominator here have a 2 and an x. I could divide both of those numbers by 2 and an x. So I'm going to factor the 2x out. If I do that, then I have x here plus 2. Okay, so look, if I multiplied 2x times x, I get 2x squared, and if I multiplied 2x times 2, I get 4x. So I just factored that 2x out, and hopefully on this other side, there's going to be another something I can factor out. Let's see, this has 3 x's, this has 2 x's. So they at least each have x squared, right? So I can factor out x squared. Okay, let's check ourselves. X squared times x, that's going to give me x cubed. So that's the first term there. And x squared times positive 2 is 2x squared, and that's the second term there. So look, they have x plus 2 in common, right? This one has x squared, and it's missing 2x, and this has 2x, and it's missing x squared. So to get that common denominator, I'm going to multiply this side by x squared over x squared. It's like a puzzle, you guys. That's why I like this, is that you're just trying to like answer a puzzle. Like a game, like it should be an app, like a add the rational functions puzzle game. Okay, I was busy entertaining myself. 2x over 2x. So what do I have? I have x squared times 1 is just x squared. Plus on this side, I have 2x times 1 is just 2x. And then my denominator is a big one. It is x squared times 2x plus 2. But you guys, there's a lot of reducing I can do here, and I'm just going to play around with it again. It's like a puzzle until I get something that I think might reduce better. Like I could factor out an x on the numerator, right? And I get x plus 2. And then on the denominator, I could factor out, oh, I didn't write down the denominator correctly, you guys. Did you see that? What did I do wrong? I'm sorry. It's late. This is the last one I'm going to make tonight. My denominator is x squared times x plus 2 times 2x. Okay. Okay. Still playing around here. Oh, look, it has an x plus 2, right? Look. Watch. Look, you guys, I just did math. I just mathed. X squared times x plus 2 times 2x. As long as they're all being multiplied together, look, I can cross off this, and I can cross off this, and then I have, what do I have now? Watch me now. Watch me now. X over x squared times 2x. But look, each of these has an x, and as long as I'm multiplying them all together, I can cancel that x out. You wouldn't normally be able to do that if, well, watch here, I'll expand it for you. If you were adding something together, you couldn't do that, but since it's all multiplication, but let's just expand it. X squared is really x times x, and then 2x is really 2 times x, but I could, basically write it like this. And then you can really see this all reduces down to, when I add those together, 1 over 2x squared. Okay? And the only way to get better at this is just to do different problems over and over again, and you start to see some patterns. Like sometimes it's super easy for me to factor something because I've seen it before, I know how it works, and the only way you get there is just to practice over and over again. So that's about enough time for this video, but please let me know if you need help with more practice problems.